And then we can rewrite this as the absolute value of the sine, because we don't know the sine of the sine x. So we have to take the absolute value. So finally, you get the plus minus the absolute value of sine x over the 1 plus cosine x. And later, we will see tangent half x has the same sign as the sine x. And then when we just use the sign, the SIGN of the sine x, to determine the sign of the tangent half x. And we'll talk about this later. And we will learn the Math 103. We have such an important property about the radical. We know the square root of a squared is equal to the absolute value of a, right? So right now, this is the square root of the sine square x. So you may just treat the sine x as the a, and then you get the absolute value of the sine x. Okay. And I just say we can prove tangent of half x has the same sign as the sine x. And let's first look at several values to see if this is true. Okay, let's move to the next page. So for example, we can have the x equal to half pi. Then tangent half x is equal to tangent of the half pi over 2, and this is equal to tangent of the pi over 4. We know this is equal to 1, right? So definitely it's bigger than 0. Okay. So then how about the sine x, which is equal to sine half pi? This guy is equal to 1, so positive, right? So in this case, tangent half x and sine x definitely have the same sign, right? Now let's look at another example, another value of x. Let x be 7 pi over 2. Okay. So now, in this case, tangent of the 7 pi over 2 divided by 2, then you get the tangent of the 7 pi over 4. And tell me which quadrant this 7 pi over 4 is in. 4, right? So actually, you may write the 7 pi over 4 as the 2 pi minus the pi over 4. If you kind of see this, you may compare the 7 pi over 4 with the 3 pi over 2. So definitely 7 pi over 4 is bigger than the 3 pi over 4 over 2, right? And but this is less than the 2 pi. So it's in the quadrant 4. And then to find the reference angle, we may just use the 2 pi minus the 7 pi over 4, and then we get the pi over 4. So in this case, so in this way, you can rewrite the 7 pi over 4 as the 2 pi minus the pi over 4. So that means the reference angle for this 7 pi over 4 is the pi over 4, right? And in the quadrant 4, tangent is positive or negative. Negative, right? So this is equal to negative tangent of the pi over 4. And this is equal to negative 1, so which is negative. Now let's look at the sine of the 7 pi over 2. And we can write this as the 2 pi plus the 3 pi over 2, because the tail rate of the sine is 2 pi, right? So we can just throw away this 2 pi without changing the value of the sine, and this is same as the sine of the 3 pi over 2, because the 2 pi is the tail rate of the sine function. And we know sine of the 3 pi over 2, this is equal to -1, right? So which is also negative. So by these two examples, we are more confident in such a conjecture that the tangent of the half x and then sine x have the same sign. But this is not a proof, right? This is just some experiments with this conjecture. And from this experiments, you can gather more information about your conjecture, and then you can become more confident in your conjecture. But we have to find a way to prove it, okay? So now, let's just prove this conjecture. And this is the one problem on page 545. It's the problem 83. Show the tangent of the half x has the same sign as the sine x for any real number x. Okay, now let's prove this. So page 545, problem 83. And first, let's consider the case where the x is between the 0 and the pi. So the case 1, net x between the 0 and the pi. And then we divide each part by 2. Then we get 0 less than the half x, which is less than the half pi. So half x is in the quadrant 1, right? Then we get the tangent of the half x is bigger than 0. And also sine x. We know in the quadrant 1 or quadrant 2, sine x is positive, right? So sine x is bigger than 0 too. So in this case, both the tangent half x and the sine x are positive. They have the same sign, okay? Checks. Now let's look at the case 2. When the x is between pi and 2 pi. So in the quadrant 3 or the quadrant 4. And we still divide each part by 2. Then we get half pi less than the half x and less than pi. Okay? So now this half x is in the quadrant 2, right? Half x is in the quadrant 2, so bigger than half pi and less than pi, so in this quadrant 2. So in the quadrant 2, we know sine, okay, we know the tangent of half x is negative, right? Tangent of half x in this quadrant 2 is less than 0, okay? So this x here in the half x actually is in the quadrant 2, right? So half x is in the quadrant 2, tangent half x is negative. And now let's get back to this x. X is greater than pi and less than 2 pi, so that means x is either in the quadrant 3 or the quadrant 4, right? And this just implies the sine x is negative. So, but now we know for x between the pi and the 2 pi, both the tangent half x and the sine x are negative, right? So, tangent half x less than 0 and the sine x also less than 0. Okay, so we verify this case.